Okay, so today we are going to start this cycle cancelling algorithm. Write the topic like this. Minimum cost flow problem. You also have to help me if I stuck. So first point is we can solve any instance of the minimum cost circulation, a minimum cost problem, minimum cost flow problem. Flow problem. Using natural generalization of the Ford-Fulkerson algorithm. Ford-Fulkerson. Ford-Fulkerson augmenting path algorithm, to be precise. It is called cycle. Is somewhat related to Ford-Fulkerson. New point is this algorithm is first developed by Martin Klein. The year 1967. It is believed that before that, A.N. Tolstoy studied railway transportation problem, which is similar to this algorithm. And very recently in 1920s, and very recently these two professors in 1989, they revealed one algorithm which is a special case cycle cancelling algorithm. This is somewhat theoretical background. Okay. Let's see. As I said, that Ford-Fulkerson minimum cost flow is a residual graph problem. That means you have to find a residual graph. Algorithm similar to Ford-Fulkerson is selecting arbitrary augmenting paths. Now, in case of Ford-Fulkerson, we select arbitrary augmenting paths. Is insufficient for finding minimum cost path problem. So this is one good point, that because we used to choose arbitrary, that means random path for Ford-Fulkerson algorithm. So this is a drawback for Ford-Fulkerson, because if you choose random path, you may end up getting most costlier path. Okay. Instead, the goal is to identify the cheapest augmenting path. Cheapest augmenting path, that is a goal. But if you remember, Ford Fulkerson randomly choose any path, so that is a big drawback. So this is the different from the Edmond curve algorithm, which focuses on fewest edge path. Okay, traditional breadth first. So Edmond curve also having breadth first, and Ford Fulkerson using DFS. Digest algorithm doesn't work either due to the negative cost case. Now, digest algorithm also will not work because it never responds properly to the negative cost edge. Bellman-Ford algorithm is a suitable alternative, but it is crucial to note that it won't function if there is a negative cost cycle. So algorithms have drawback to deal with. Cheapest augmenting path algorithm, what it says, implement Ford Fulkerson by selecting cheapest augmenting path with respect to the residual cost. However, to ensure its success, it's crucial to demonstrate that the algorithm does not generate a negative cost cycle as shortest paths such cycle are absent. That means Ford Fulkerson will only work properly when there is no negative cycle. Okay, Ford Fulkerson will only work properly when there is no negative cycle. So based on that, you have cycle cancelling algorithms. The approach, which is known as cycle cancelling algorithm, starts with the maximum but non-cost optimal flow, gradually reducing the cost while maintaining the maximum. So maintaining the maximum flow as well as minimum cost. These two things you have to maintain. Ford Fulkerson establishes the maximum flow. You see, this point is important. Ford Fulkerson establishes the maximum flow that has no augmenting path, and the theorem below similarly shows that cost optimally is achieved when there is no negative cycle. Ford Fulkerson will give you results when there is no negative cycle. So what it says, flow F is cost optimal if and only if there is no negative cycle. That means Ford Fulkerson, if flow F is optimal, which optimal algorithm you can use Ford Fulkerson here. But what is the condition is that should not have any negative cycle. What about Bellman-Ford? Bellman-Ford algorithm utilizes identify negative cost cycle, which can be used as the augmenting cycle to reduce the flow cost while maintaining stability of the value. So next, so this is how this algorithm, cycle cancelling algorithm, will work. What it will do? Find a maximum flow F with any max flow algorithm that we have already done using Ford Fulkerson. While there is a negative cycle, negative cost cycle, okay, not negative capacity, cost in GF, augment the maximum possible amount of the flow along the cycle. Whenever there is a negative cycle will come, will augment the possible maximum amount of flow along the negative cycle. So what is the duty here? Duty here is to find the negative cycle if there exists any after you apply Ford Fulkerson algorithm. So one example we will take, we'll understand this very well. Okay, so what this algorithm says, so let's say this is the output. Above graph is showing the feasible solution using max flow. So you just can write here the graph here is showing the feasible solution don't write feasible solution using max flow. That means this output is got using max flow. Let's say some situation, this is the final outcome. Now we will find the residual graph. Now we will find residual graph. Residual graph already you know. Slightly different way we will represent it. Okay. So first, what we have to do? So consider the residual graph by making Consider the residual graph by making direction of the direction of the flow towards opposite side. That means, okay, so that means you can see that opposite side, and also make the cost as opposite sign. That means if it is positive, make it negative. If it is negative, make it positive. Okay. So what we'll do here, we'll just draw the residual graph. So here you can see this direction 4 to -5 is already going. Capacity is 4, flow also 4 is happening. That means nothing much we can send. Already maximum has been sent. So this direction is not at all working. What we will do, we'll send everything opposite side. And also this cost has to be negative, but 0 negative means 0 only. So this will be this and comma. Okay, make it 4 and here also same thing we'll do. Here this 2 to -1 maximum flow is 3, also 3 is passing by. So what we'll do, we'll just make the opposite direction. So this is residual graph. Opposite direction, we'll make the cost 7 and then this will be 3 only. This is 1. What about the other two? Other two. This thing you tried, student? Another question. Oh, that's a mistake in last. Then you have to find the negative side. Okay? Then you have to find the negative side. What shall we do here? First thing is that this side, let's say, here no problem happening, right? 3 0. So let us pass this whole, because here 0 is passing and capacity is 2. So we'll make, there is no issue. I mean, whenever there is a thing, so okay, we can make opposite. Shall we make opposite directions? Shall we make opposite direction? Opposite direction only will be making when there is a problem. I mean, the capacity and the flow tallying are equal. Otherwise, no need of making opposite direction. For the time being, let us see. This, it will be -3 and then total amount we are sending. There is no need of making the opposite direction for the edge. For the timing, hold on. We'll see if it is wrong, we'll come back. Okay. And then this side, what will happen, students? First, let us draw this direction and all we don't know. Let's say. So cost is 2 and out of 4 capacity 1 is flowing by. How much is remaining? 3. How to send these 3, friends? Hmm? Shall we make it -2 and 3 here? And this side it is 2, 1. For the timing, might be little bit wrong and all. Let us do it. So this is a scenario, let's say. Okay. Now you have to find, now you have, so this is the diagram. Now you have to find the negative cycle if there exists. If there is any. So let me make a color change here, negative cycle. So this is one starting point, this. Then you have this. Then you have this. Then you have this. So it's a negative cycle, friends. This, 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 and this is a cycle. Starting from here, again, I'm ending here. So in this cycle, so we got a cycle. So what is the cycle? This thing, 4, sorry, -5. No, just to say -5, 4, -1, 2, again 4. This is a cycle. What this? -5. Sorry. So here, what this algorithm, again, let us come to the algorithm here. It says find maximum flow, that is done. While there is exist a negative cycle in GF, augment the maximum possible amount of flow along the cycle. Okay, augment the maximum possible count of flow. Now same way we did in our this one, full cuts earlier. What we used to do first, when you randomly choose the path, then we see the minimum cost. Then you log that path. Remember, that is the maximum flow, means that minimum wala path you have to find. Which is having minimum here? Minimum flow in this cycle. How much it is? 1. Why I did mistake here? No, this is 3, 1, 4 I took. It is only 4. Why I took this? This should be 2 and 2, maybe, right? Here 3 and 1, 4. Already 1 has passed. So 3 is remaining, no? So either L 2 and 2. A mistake, right? Because here capacity is 4. 1 is already passing. Remaining is 3. 1 and 3, this one. Okay. So now minimum flow is 2. So according to the algorithm, once in, I'll come to your doubt. So 1 and 2, this is 1 and 2. So what is the minimum flow here? 2. Now this 2, this flow 2 has to be distributed alongside the negative cycle. Okay. So again, you have to draw this figure, redrawing, updating. What is happening here? 4 -5, 2 -1. Now 2 is the minimum. So 2 is the minimum. So we are redrawing it. Okay. So what will happen here? 4 is the capacity. So this side it will be 2. This side it will be 2. This is done. Next, you just make it this 2 to -1. You have to pass 2 now. The 2 to -1, you have to pass 2. Already the capacity. How should we manage it? How should we manage it? But this side plus 7, 2 or 1? 1. You are saying, okay, 1, okay, 1. This side, 7, minus 7, 2. 3 has been distributed, minimum is here. Shall I change the direction, I guess, right? Minus 2, 0, shall I make it? And then this guy, I'll make it plus 2 and 3. Capacity is how much? 4, so no problem. Okay. So this is a situation. Now what is the total cost? So now you have to update it. So let me see whether it works. So now update the graph. What did it look like? And this side it is minus 2 comma 0. Okay, I'm going with your suggestion. He is telling because it is residual graph, so this won't be 3, it will be 2 only, because total capacity is here 4. Here total capacity is 4, so remaining flow can be 3. So 3 can be distributed, and here it is 2. So this 2 we are making it 0 here, 2 0. So this 2 also will be added. And then what you suggest? Already 1 is there. 1 is also there. But what about this one which is passing? Hmm. Second, we are doing part which is unflow is 2. And when we are looking at residual graph, third graph, that when we are changing the direction, so it will be plus 2 comma 2 and which is 2. It will be 2 minus, it will be 3 only. For the timing, it will be 3, okay? Let us do it and then I'll come back again, okay? So this is 2 comma 3 only that we have decided. Now update the graph. Just simply adding these two here. Already 1 plus 2, 3. 2 comma 3 here, okay? Now update capacity was 4 and now passing only 2, 0, 2 comma 4. This side 3, 2 comma 2. This side how much it will be? 7. Uh, 1 comma 3. 2 comma 3. This side how much it will be?